In this video, I'll be showing you how to use CopyCat to train upscale for a specific shot. Say you really like the emotion of the actor here, and you really want to emphasize this emotion by having a close-up, but unfortunately you didn't get that shot on set. Now if you crop into the footage, it becomes very pixelated. Luckily, with CopyCat, we're able to completely bypass this physical limitation and get something very close to as if shot on set. The key difference between using the Upscale node and the CopyCat node to upscale footage is that CopyCat will be trained on your footage and therefore give you better results specific to your shot. Before showing you how to approach this, let me first explain the trick about using CopyCat to train an upscaler. Basically, we don't actually train CopyCat to directly upscale an image. Instead, we train it to take a badly upscaled image and turn it into a nicely upscaled image. So to do this, we first find a shot that is up close and similarly lit to the crop we just made. After that, we'll start the data creation process by manufacturing a pixelated version of our footage. The process is essentially to downscale the footage to the resolution of our punched in shot, and then we upscale it back up to the original resolution. This will leave us with a pixelated version of our training plate and the respective ground truth, which is our original footage. So we'll start by adding a reformat node and downscale it to around the same resolution as our crop. This is to ensure more similarities between the input that we'll be upscaling later and what we'll be training on. It's important here that the filter is also set to cubic within reformat node. We then want to go ahead and make a grade node, and this is just to stop concatenation, nothing else is being changed. We then want to make a second reformat node. This time we're scaling back up to our original resolution. We also want to set the filter here to impulse. We've now successfully generated our input data, a pixelated version of our plate, and our ground truth data, the original high resolution plate. Afterwards, we then add a frame range node set to 1 to 1, and then we frame hold 4 different frames throughout our image sequence. We then add 4 crops for each of those frame holds. Each crop looks at specific detail that we want to retain during our training. We then bring all of these together with an append clip node, and then duplicate it so that we have the same crops on the high resolution pipe as well. We then take the ground truth pipe of our CopyCat node and pipe it into our high resolution original plate. And then with our input pipe, we want to pipe this into our pixelated plate we just made together. Now within the CopyCat node, we can use a low amount of epochs as we're already using the initial weights of upscale. In this case, 2000 is enough. And lastly, we can use a crop size of 32, and this is because upscale is a localized effect. Compare this to human matting, which needs more context to understand what is a human being in an image and what isn't. In this use case, we're looking at how the pixels change between a low resolution image and a high resolution image. We don't need as much global context, so we can use a smaller crop to refine and train faster. Now after we hit start training and training's finished, using a reformat node, we want to take the crop that we had made at the start and bring it up to the original resolution of the footage. We want to make sure the filtering here is also set to impulse. Then all we need to do is plug our inference node into the reformat node and we're done. Looking through our inference node, we can see how CopyCat has learned how to take something very pixelated, a quarter of the original size, and upscale it by 4 to a much higher resolution, high fidelity image.